Okay, it's my understanding we're live now, and I'll just wait until we get right to 9 o'clock in New York time to officially start. Okay, welcome everyone to the second day of ICFP 2020. I'm the program chair, Adam Czaplicki, and it's my pleasure to introduce our second keynote presentation, which will be by Evan Czaplicki. And I actually first met him when he emailed me for some advice about attending a workshop in programming language design. We were both working on web programming languages and are both part of this sort of minority that almost gets affirmative action sometimes in our PL conferences of full-on language design, where you're not just studying one question, you're doing the whole shebang, including dealing with issues of documentation and usability and adoption. And since then, Evan's gone way beyond anything I've ever done in taking those elements seriously. He's the creator of the Elm programming language, which he actually began as an undergraduate in a senior thesis, I believe. And it's become a real serious open source project with use in industry and everywhere. And we're all probably aware, if you're like me, you haven't experienced this firsthand, but you know there are people out there on social media doing things like posting photos of themselves and saying, look how good I look, and everyone else adds likes and so forth. That's what Evan does for the error messages of his compiler, and they go viral. And that might be part of the story he's about to tell us, which involves not just technology, but also economics. Evan.
Thank you. So we can see the presentation all right, everyone?
Looks good to me.
Great. So it's a real honor to be speaking at ICFP. I sort of got into this as a fan of type functional programming in general, and have been so influenced by all the different papers that I've read throughout the years as part of this project. So a lot of the time I've spent working on Elm has been in industry. So I kind of wanted to use this as a chance to say, what are things that I have observed in that world, and are there lessons that can be useful in an academic context, in a research context? And so the structure is sort of, we're going to start with who uses Elm, sort of like on what basis it might, even thinking to give a talk like this. And then sort of go back to where did Elm begin, and then how did it proceed? What lessons could be useful to someone else who's trying to do something similar? So yeah, in terms of who uses Elm, the major categories right now are individuals, companies, and educators. So individuals are always going to be, well, in the case of Elm, are sort of the heart of the project. So you get people doing quite wild things. So there's a group of people who are really into 3D graphics and physics. So we got a little car flying around. And so there's some segment of the community that's working on how do I get realistic shadows and textures. I mean, realistic with limitations, right? Like the ground is pink here. And like another example is we have a retired math professor who got into Elm and was just excited to get LaTeX documents of some definition working with Elm and able to be shown online. And so he's working on a way to share those. And perhaps interestingly, Lambdera is another project about Elm, about hosting. So he's using someone else's Elm project. And then you get people who they are sort of experiencing the joy of typed functional programming for the first time. So this tweet, he's sort of saying, I updated 11,000 lines of code and everything worked as before once it compiled. And he says only Elmling gives you these guarantees and confidence. Well, Haskell and OCaml, there's lots of languages that can do that, but for a lot of people, Elm is their first entry point into ML family languages that are really from that tradition directly. So in terms of companies, it's usually teams of 2 to 20 developers. That's sort of the shape. So a couple examples. One is NoReading. So they have a writing and reading product for middle schoolers and high schoolers. So this particular one is you write a paragraph and then how do you recognize what's the claim, what's the evidence, what's the reasoning? And so there's all this tricky logic in word separation and how to render the curves around these highlights properly as the mouse is moving, all this. Another cool one is called Keystone Health and Fitness. So this is a company about helping trainers and individuals track their health and like what's my exercise, what's my diet. And so this one I wanted to share just because they have a lot of cool diagrams. So IBM, there's a team in IBM that had a Elm project that was showing these decision tables. And so this isn't to say like all of IBM is using Elm. It's like a team within it who had the freedom to be different than other teams did this project. Another cool one is Ableton, has like a beat making website that's done in Elm, so you can learn the basics of drum machines. And so like I don't have good images for these because like with the SoundCloud, it's like there's a guy there who's really into 3D graphics who is also at SoundCloud, and they'll do internal stuff. And at Ford, I don't know what the internal things look like. So it's essentially at a stage where there's teams using it of a 2 to 20 size, and it can get used in big companies, but often on not the main thing, right? So like, I believe there was a project at Microsoft on quantum computing that used it. So it's like Microsoft used Elm, but like in this specific kind of way. So the other category is educators. So McMaster University and UChicago are sort of the two big examples of this. So McMaster has a thing called McMaster Outreach, and it's about teaching programming to 4th to 8th graders is what I see a lot. I don't know the details of this extraordinarily well, but it's just been interesting to follow their Twitter and sort of see what I see. So early on, they had this style of like, you give kids the ability to make circles, rectangles, and they're just overlaying them. So like when you see that the pig in the middle there, it's a pink oval with a pink oval with 2 black circles, a triangle that's rotated. So the programs they're writing are really declarative. Here's a triangle, rotate it, move it. Here's an oval, rotate it, move it. And that gives a way so they can get something on screen and do something cool, but they're also using a full programming language that some company could use to make a commercial product. And so they can start expanding and say, okay, well, let's make it vary based on time. We'll have a function with a time argument. So this house example, it like moves around a little bit when you see it online. So they've moved on from this to doing comics. And so the idea here was we have this way where kids can create some sort of visual, but can we make it more engaging and help the learning work better if we incorporate it with some other topic? So one of these comics is about global warming. Another one is about the book The Giver. And so you're sort of doing a multidisciplinary approach, and you're trying to do it with teamwork and seeing how that works. So they have a poster about what they were trying to do, and you can see the Elm code and the resulting comic page. So their big statistic is that 12,887 new coders. So this is a really cool project. And the other one is at UChicago. So Ravi he teaches a course called CS 223. And the idea is to talk about purely functional data structures in the context of Elm. So one of the things they experimented, at least in 2015, I don't know if they still do this part, is they would have a visual component to the homeworks. So you can see visualizing red black trees or visualizing approximation of pi, I think. And the other thing that they've done since 2015 up till now is final projects. So students are making chess or Conway's Game of Life or a finite state automata runner, where you can design an automata and see what strings will go through. So it's been really cool to sort of see what the students have been able to create, and they're doing so in a typed functional language, where you can really get this sort of visual feedback. So those are sort of the major groups these days. And so I want to, from there, I want to make a note. It's not to say like, whoa, this is so great. It's just like, this is where it's at. It could be better. It could be worse. And like, we're just going to look at what happened to get to this point. So the beginning was, I was an undergraduate student and I really enjoyed using standard ML, OCaml, and Haskell. And that's something I want to really emphasize, is like, this project is building on so many years of compiler work, research work, community work, of exploring these ideas and popularizing them. And I don't want it to sound like I think that's not the case. So I personally came from a background where I really liked making visual programs. I was always making games when I was learning programming. And I was confused by web programming in 2010, 2011. And this is the time period where it's a lot of jQuery, it's a lot of callbacks. If you want to have the same visual component on 10 different pages, there's not really a good way to share that code. Like, it just felt like there were a lot of lessons from even like just there's a lot of lessons from other languages that hadn't really been applied in JavaScript yet. And I wanted to do a senior thesis. So I sort of saw like, how can I take these languages, which I really love, and put them in a context where I can make these visual programs that I enjoy, and where there's a community that sort of is in need of more rigorous design, or some people within that world think that they could benefit from that. So the sort of core of it is this idea: how can I get that joyful feeling that I personally have from these languages in browsers? So once my thesis was done, the first thing I really focused on was learning resources. I wanted there to be an online editor so that if anybody came to the site, they could see exactly what Elm was and play around with it. And I think this was actually really big for Elm early on, was that you didn't need to install. At that time, it was really, really difficult to install. It was like, you first install Haskell, then you install the Elm compiler package, and it has to build, and that might take an hour, and it might fail for this or that reason. So it's like, you can just go online, you can use Elm, you can see if you like it. And so today, it looks sort of like this. So you have your simple hello world example where we can say hello ICFP and see it update. And you can sort of see more complicated programs. So this one, I mean, it is more complicated technically. It's just a little counter. And the structure is, we have a model of some integer that we're tracking, and we have this update function where you can increment or decrement, and based on which of those it is, I'm going to update my model accordingly. And then finally, there's a view function that says, hey, take that model, draw a button, show the number, and draw another button. So if you wanted to add a bit to this program, we could say, okay, I want to add the ability to reset. And in my view, I need to add, oops. Okay, so now I have my updated program and I can reset the counter back to 0. So this is sort of the basic shape of an Elm program. Is we have a pure view function to show stuff on screen, and then we have an update function that's going to step that model forward. That's going to be rendered on screen. So yeah, so this I think was huge to early people sort of getting an idea of what Elm was and seeing what it could be, right? So when Elm first came out, it was like people were like, oh, functional reactive programming is exciting. Functional programming is exciting. This language, like clearly I can't make a website or do what I want to do, but there's ideas here that I want to explore more. So after that was out, the next step was just like, what are the baseline features to be a plausible language? So like we need to have a module system. We need to have some kind of JavaScript interop. Let's talk about those briefly. So modules in Elm are very simple. And we looked at more complex module systems like Camel, but sort of felt that let's start with the minimal version and see if it makes sense to become more complicated, because it's always easier to add than it is to remove. And then JavaScript interop, I wanted to have a pure language with types. So our JavaScript interop was quite restricted. Essentially, you can send messages out to JavaScript. Anything can happen out there, and messages can come back into Elm. And so there's this really clear delineation of, this is Elm, the types all are good, we won't have runtime errors in this context. But by doing that, you're sort of not allowing a deep integration where someone might want to call a JavaScript function directly, and instead they need to do it this other way to maintain these other things. So that's a trade-off that was made in Elm that has had repercussions throughout the years, way more than, I don't know, I ever thought. So yeah, like fast type inference for the first like year or two, Elm just like took forever to compile large files. And it's because I was looking at the idea of how type inference worked as opposed to the paper on how to do it efficiently. And then having an extensible record system. So I just want to take a moment and shout out some of the papers that were really helpful with this kind of work. Thank you again. So at this point, we start to get, oh yeah, it makes sense to talk about like the medium in which you're presenting these ideas. So in Elm, I'd always blog about releases. And so initially I would share things on Reddit, and at some point there was enough people who knew about Elm that it would get shared on Hacker News. And so what's important here is that Reddit and Hacker News are both extreme like crossover places, right? So people on our programming are from all these different language communities. So a lot of different people are seeing it, and some fraction of them might like what they see. And Hacker News is like lots and lots of different people with lots of very strong opinions. And again, some of them might like what they see. I did a talk a while ago called The Hard Parts of Open Source, that talks about like in having an online community that mixes so many different people with so many different values, you often get some negativity in those places as well, but there's nowhere else that's like, the reason I have this little chart at the bottom is like when you have a blog post, a lot of people can end up coming to visit your site, and some fraction of them may stick around and try it out. So having these blog posts is, I think, probably the most important factor in like the early uptake with Elm. So conferences also matter, but like it sort of depends. So early on, there were conferences that gave Elm a shot. So like the emerging languages camp, I got to talk to a bunch of people interested in new languages. And that was a really good sort of way to reach people that we wouldn't have connected otherwise. And you can also reach people who aren't very online, right? So maybe there's people who aren't on Twitter a lot, aren't on Reddit a lot, aren't on Hacker News. How do you talk to those people? So in terms of language adoption, the crossover conferences where it's not, I'm talking about Elm at a JavaScript conference. There's a conference of people who are interested, maybe they're doing front-end development, but they're interested in different approaches. So you get to talk to an audience of people who may have never seen your work, and some fraction of them will stick around. So if you're thinking of conferences as a way to grow things, it's definitely much slower than blog posts. And you want to be thinking about what kind of crossover does this have? Is the audience, is the language interesting to the audience that's there? There's also word of mouth. I don't think you can grow a language on word of mouth only now. I think you might have been able to do it in like the 80s to some extent, or to a larger extent in the 90s to some extent. So really all you can do about word of mouth is try to set the tone. And so that's something I try to do in conference talks to at an Elm conference, is like, I don't want Elm to be a language where people are mean to other languages or think, that language sucks or da-da-da. It's like every language is doing something different and it works for some set of people. So I try to model like, being negative to other languages, it's like, it can work, but I don't think it's like a really great thing to do. So the point is just like, you can model different behaviors through your blog post and through conference talks. And I think that's an important thing to do, because if you don't, the internet is an angry place and things might go a different way than you'd hope. The other thing is like, the more like, if you happen to do a blog post that's like of the moment, the anxiety that happens to be surfacing on Hacker News is like, everyone's worried about, are my pages loading quickly? If you are talking about those things, you're going to have more people reading. You're sort of in that conversation more. So I did this talk a while ago called On Storytelling that focuses a lot on blog posts and how do you interleave that with your technical work. Okay, so coming back to this timeline, programmers are starting to take a look and they're saying, okay, there's something interesting here. And so I started working on a package manager. Now, part of why I wanted to work on this, I don't know if you can see that bubble, but I was thinking like, why is it that, Haskell and OCaml, I think they're both great, but I was seeing like Haskell sort of more talked about, more in this like conversation around this time, 2014. And my theory on one of the big factors was that the package manager for Haskell came out, I don't remember the exact dates, but like many years before the one for OCaml. I want to say like 10 years or something like that. And I think that was a really big deal, because you come to the language and the language is what it is. People will like it or not. But having that package ecosystem sort of helped you get deeper into the language and sort of say, oh, I really like this. So in Elm, we did a package manager that was specific to Elm. And the pros of doing it specific to Elm are all of our packages are written in Elm, whereas some languages in the space, they piggyback on the JavaScript package manager. And so they're getting more of a mix of JavaScript and whatever the language is. And like I was saying before, in Elm, the goal was to have this pure functional language. So one of the benefits of everything being written in Elm is we can do automatic semantic versioning. So I can go look at all the types of the public API and detect, hey, there's no changes, there's a minor change, a function was added, or there's a major change, one of the types changed, or one of the names changed. And so that was in our package ecosystem from the very beginning. So all packages have followed these rules the whole way along. The other benefit is we don't get the security vulnerabilities to the same extent that you have in JavaScript, where a package may just add a script tag on initialization, or even more wildly, on install, it can run scripts and stuff if you don't have the right flags enabled. So we are not vulnerable to those to the same degree. The cons is that we're not piggybacking on the JS ecosystem. So when this choice was made, some of the critical reviews were like, well, I want to use D3 for visualization. I want to use React or D3, or sorry, like this chart library, whatever it happens to be. And you can't just have that directly in the package ecosystem. So I think this definitely slowed adoption, but I'm not sure if we'd made other choices. Like there's other trade-offs, which we'll talk about later. So the other thing that I worked on in this area was render performance. So in Elm, you have these functions that go pure functions from data to some sort of visualizable data. So if someone said view Kwame, you're going to allocate data that represents what's going to show on screen, and then that's going to be rendered on screen. And then say the next frame, someone says view Hobson, again, we're going to allocate these nodes. But instead of rendering it all on screen, we're instead going to diff to see if there's any changes. So we say, oh, okay, there's a little change in this string. So this diff is then just a spot change in the DOM. So the reason Elm was doing this is that changing the DOM is like by far the most expensive thing in a web application. It's like you have to be doing like 3 physics kind of stuff for the computation to really compete against the rendering work that's happening. So Elm was doing this, and separately, independently, there was a project called called React coming out of Facebook, and it was using similar techniques to render HTML. And I wasn't paying too much attention. We sort of just independently came to this conclusion of, if you build up a data structure and do your work on this light data structure and then make minimal changes, things will be faster. So I started paying attention to this when a project called Ohm in ClojureScript, it built on React and made this observation that if you have immutable values and you know that x equals y, well, that implies that view x equals view y. So what's even faster than having this light representation and doing a diff is like not even building the light representation at all. And so I saw this and I sort of saw, hey, I should do something with this. This seems like a really promising thing for Elm, where people maybe want to do more with HTML. And so I look at it and say, well, with pure functions, then this actually is a safe optimization. And so I do a bunch of work on optimization. So essentially, there was like a big race to see who could get the best performance on these things. And so if you can see, Elm does quite well. This is like modern day results. And like big competitors are like React Redux. Angular is another big one. Vue is another big one. So Elm is doing really good on these numbers. And during the time of the sort of like race to get good numbers, a lot of people were giving Elm a shot because it was getting good numbers. And so people do like really kind of rigorous versions of this. So I just wanted to show briefly. So this is a benchmark that's trying out this like diffing algorithm, really testing all the different aspects of it. And so to give some perspective, like there's a lot of different frameworks that one can use. So like Angular is one, we have Elm, React, and Vue. And so when you look at the numbers, Elm is doing well on the speed, but sort of interestingly, Elm does quite well on memory allocation as well compared to other options. So I don't know, there's the interesting thing here is that like immutability and is not necessarily a downside when it comes to performance in these contexts. And so that was something that I sort of took to heart in the future, which is like, how can being a pure language with immutability, give us advantages that you just can't really get in other languages? And can we focus on those technically to tell stories that are compelling to front-end developers or developers in general? So I have a brief aside. I think there's time. So if there ever is a future performance race, there's this idea so WebAssembly is like, instead of going to JavaScript, we can compile to this more bytecode kind of language. And there was this idea out of some folks at Mozilla. And it's like, okay, we have this pure function. So what if instead of allocating everything into the young generation and then maybe some of it gets stuck in the old generation, we end up doing more cleanup there. Instead, we have two regions that are specific for our view function. So when I call my view function on a frame, I start allocating into that region. And maybe I need to do some in the young generation, but I try to do as much as I can in that region. And then in the next frame, we start allocating into the second region. And we do our diffs. And instead of doing a garbage collection, we just move the pointer back to the beginning of the region. And we sort of free up, we space out how frequent it is we end up doing garbage collections. So if there is a future performance race when WebAssembly comes, this is something that I think it makes sense to look into. I don't know, I don't have plans to work on this anytime soon, but it's something that I'd be really curious to see what kind of results you get. Another thing that is sort of interesting in Elm is I made the choice to not allow cyclic data to be created dynamically. So I thought there might be some potential, like what if we do reference counting in the old generation, or maybe this opens up some possibility that hasn't been that explored before. So there's a lot of cool things to do here. So, okay, taking a step back, this work on the packages and the render performance in particular, a lot of people were seeing that and a lot of people were coming to check out Elm. And at the same time, there were these competitors that were showing up, like React was getting a lot of usage. People were curious and checking it out. And so I started to get anxious about competitors. Is there space for everyone? And so the best advice I got on this was just that Ruby, PHP, Python, Perl, if you look at them just with your language hat on, they're pretty similar, but they all exist. They all have different communities that like different things and emphasize different things. And so the observation here is just like, people really do have different preferences, and a language can't cover it all. So when you have different options that are closely related, people find that they can find the place where they feel most comfortable and it works most for them. Like maybe they value extreme freedom or extreme concision most, whereas someone else is like, I really want clear, readable code, and I don't care if it takes a couple extra lines. So everyone can sort of find a spot that works better. And so in Elm, like the fact that PureScript is out there and that ReasonML is out there, and more generally that like Clojure, ClojureScript, Haskell, OCaml, StandardML, etc. Like whenever one of these languages does well, everyone does well because they're going to bring in new people, and then you're going to have this cultural sorting of people finding where they feel the most comfortable. So the advice I got from had the opportunity to talk to the guy who created Python. And his advice was just do a good job. Like, don't worry too much about this stuff. If your language is strong and it's speaking to real people out there, those people are going to keep using it. Like, that's the foundation of the community, not that there's a zero overlap with anyone else. So yeah, so we had these new people coming in. The competition was benefiting us. Like, people were coming from React and saying, oh, this is similar. But they'd come and sort of be confused by the error messages. So I did a big batch of work on improving error messages in 2015 and another one in 2019. So these days, the error messages might look something like this, where it's like, hey, we have an if where the condition is an integer, but I need it to be a bool. And then there's a hint for people coming from different backgrounds, maybe from Python or JavaScript. Elm doesn't have truthiness, so you need to do the conversion explicitly. So I wanted to do a little demonstration of like some of the errors to sort of, and encourage you to try yourself to see what they're like. So like this program, this is a JavaScript style import, and the error message says, hey, I got stuck here. And then it sort of shows, here are valid import declarations. You don't have to go to any docs, just like do one of these things. So I can say, okay, I want exposing. So say I make another error, like in this function, I forget the E. So again, we say, hey, I don't know what this field is. It's usually a typo. Maybe first name should be first name. So it's able to give a suggestion of what the fix could be. And similarly, if someone's new to Elm, they might say, oh, you can just use plus signs like JavaScript to append strings. And so, hey, I can't do addition on string values. The plus operator only works on int and float. Maybe switch to this operator to append strings. So the goal was like, to what extent can the compiler be the learning resource where you can just make mistakes and the compiler will help you fix them? And so I think this is part of why, in a learning context, like with the 4th through 8th graders at McMaster, like cases where, say I forget this closing brace, the syntax is saying, hey, I was expecting a closing curly brace, try putting this next. So really trying to help people get all these errors that, like, in the first week or two of programming, you're going to see a lot, and then you won't see again. So it's sort of a blind spot, but this, I think, was really huge in bringing people into Elm. So at this point, we had more people coming in, but we were having problems with the learning curve. So we kind of had this shape of people would run into the weird syntax. So I think we definitely lose people on the syntax where they just look at it and they close the tab. And again, that sort of comes back to, like, there were certain goals that I wanted for Elm. But this other barrier, one might think it's monads, but Elm actually took a different approach than Haskell, which was just have the functions defined in each relevant module. So the basic theory is, like, you can learn addition, multiplication, rotation without learning group theory. So let's just introduce people to these ideas as they see them. And so the first time they're going to see it is with maybe, where they can always write it with a case expression instead. And so you have a really long time to sort of get familiar with this before you end up writing a task where you need to be using and then. And I think for a lot of Elm programmers, they may never end up needing to use an and then based on how other things are designed. So that wasn't the big issue. The big issue was signals. And so Elm was coming from function reactive programming, and that the hope was that signals would allow us to have interactivity without needing do notation and all these kinds of things that people could get tripped up on, but people were getting tripped up on signals. So at some point I made this thing called Start App, which was, okay, rather than dealing with these signals and making a network, I'm just going to give you a function. You give me a view function, an update function, and I'll set up the signal network for you. You don't have to worry about that. And so the effect of that was that the learning curve was lowered, and my animation's not quite right. The bump should be moved later as well. People could keep going with what they knew, but still they'd run into signals and do I need this? How does this fit with everything? So ultimately we felt that just having people work with a view and an update was actually like the ideal architecture. Like the code came out really nicely. It was easy to understand. And so we did this release, and it was titled A Farewell to FRP, where we took out signals entirely. And this post is a good lesson in terms of like a lot of things were happening here. I had learned enough about how to make a title to be read by a large audience. So if you want to get read on Hacker News, like having a title that's controversial is helpful, and you sort of have to choose like what is your, what are your personal limits? Like, are you going to be explicitly negative to other projects? I don't like that. People do it and it can work. So A Farewell to FRP was sort of saying, basically all the people who are, let's say 80 to 90% of people using Elm these days are using Start App. So we're like committing to that approach. And so people within Elm knew that. But to the outside, it's like, oh, this is a huge change. What happens to all these people who were using it before? And it's like, there weren't that many people who were using it for companies, right? Like the number of companies using it at this point was pretty small, a handful. So this title ended up getting a lot of readership, but it suggested a level of controversy that I think overstated the reality. And Elm sort of got stuck with this reputation of like, oh, there could be really dramatic changes. And I don't think that's really fair to the reality of the situation. And that's something like looking back, I don't know if I would have done it differently, but it was very costly to present things in this way. So once we got the learning curve, teams started giving Elm more of a look. Like programmers were like, this is cool, I like it. How do I get a team to care about it? And so as we got all these new people coming into Elm, wanting to use it in teams, essentially a lot of people just weren't familiar with functional programming techniques. They're coming in and saying, I want to do things in an object-oriented way. Why is that hard? Why does Elm not let me do that? Does Elm suck? Does Elm need new features? And so we ended up doing a lot of work on talking about conventions that were specifically addressing points of confusion where people felt stuck. And it was things that I wouldn't have predicted, where it's like, how do you make this reusable? And it's like, okay, well, it's a function and it calls other functions, you break out functions. But coming from an object-oriented background, people wanted a module to be like an object, and they wanted to have internal state. And so they were doing all this stuff that, like, to me, I was surprised that someone would try first. Not because it's a wrong thing to do, but just because there's easier paths. And the issue was like, people didn't know, weren't familiar with that kind of stuff. So a big thing at this time was we expanded the official guide. So if you go to the tutorial, like you're getting a guide that's like, hey, this is how Elm works. And it's got, you don't have to install anything to get going. And we're going to walk you through different examples. So like, here's the buttons example I showed before, and you can just pop over to edit it and you end up in that editor again. So how do we get this really easy learning experience that's also addressing, just like if someone is straight out of a boot camp and they've been programming 12 weeks and in JavaScript, there's just stuff that, if you don't take the functional programming course at university, it's not that obvious. So another thing we did was we did some conference talks. And so like I was saying before about Medium, these conferences were Elm conferences to Elm people. And we were just talking about this issue, like how do you grow a file in a good way? Like, let's focus on building data structures and then having functions around that. And that's how you build a module. And Richard, who's one of the early people who used Elm and was really advocate for it, he, as always, had a way of talking about it that really connected to the day-to-day programming of being a professional developer who's doing front-end work. And so, and he also made this application that was like 4,000 lines of Elm that shows all these kinds of conventions. So these things were a really necessary thing for where Elm was at that time. And so like you might look at that year and say, well, what really happened in the language in terms of technical releases? And it's like, it's not that much, but that work on making information about the conventions was really, really important. So at this point, there's an argument that Elm is a good language to use as a team, but teams, some like it, some have resistance. Oops. So when you look at what are teams asking, it's like, how are we going to hire Elm people? What's the biggest company using it? Are there going to be scaling problems? So what's the biggest company using it as sort of a proxy for the other two? Because it's like, well, if the bigger company is using it, they're going to run into the problems first and they're going to spend money to solve them. And if the bigger company is using it and they can hire, then we'll be able to hire too, is sort of I think the logic behind that question. So the only question of these that we can really answer technically is, will there be scaling problems? So I focused on asset size and compile times in the next two chunks of work. So asset size, it really matters on the web, because when you are loading a website, if you're on a bad connection, just getting the data could be the major time cost. And it doesn't matter how fast your rendering system is if the data just takes a long time to get there. And so, yeah, so this was something that was sort of like an anxiety in the front-end world. And I was like, oh, is this another performance race? Like, is this a lot of people are gonna be looking at different projects and choosing based on this metric. So I did some work where, so real world app is like a big application that all these frameworks will implement. And so you can then sort of compare them in different ways. So this is comparing what's the best case scenario for minifying and gzipping that stuff. And so in Elm, we were able to get really good results. And this wasn't any like special brilliance or anything. It was just like doing dead code elimination on a function level. And because all these other projects are in JavaScript, it's extraordinarily difficult to do that fine level of granularity, because if you have a file, it might have a top level thing that's changing global scope, this or that. So doing this level of dead code elimination is just really hard. And so so this is comparing like a really big range of this real world application. So Elm is doing quite well. There are projects that can get things even smaller. But if they're in JavaScript and you end up adding additional dependencies, you're going to have this problem of the dead code elimination is not that good. So if you can get it really small in the simple case, that doesn't necessarily mean it's going to be small in a much larger application. Whereas like the big competitors to Elm are like React Redux is a really big, widely used project. And it's quite a lot larger. And so the lesson here was kind of like, Google cares about asset size, where for them, milliseconds of page load is going to be measured in millions of dollars. But no one else really seems to care. And what I mean is, no one's switching projects based on this metric. Like it's something that a team wants to make sure is good, but it's not really driving adoption very much as far as I can tell. And so compile times, I did a bunch of work to improve them. It takes a long time to do this kind of work. And part of the reasoning was there are these larger companies using Elm, and we want them to have like a good developer experience. You know, they bet on Elm early on, and it's like the right thing to do to make sure they're having nice compile times. So it's a little small, but this project, we did like a survey of different people using Elm. So they had 136,000 lines of Elm, and they were seeing about 2.5 seconds for full build from scratch. And then incremental ones, median time was like 600 milliseconds. And then the upper range of this survey data was 278,000 lines of Elm. And their from scratch build was about 4 seconds, and median incremental was like 800 milliseconds. So pretty good. But there were some outliers in this data that we still haven't sorted out. So I haven't been able to tell a really public story about compile time. So this one was in between, but they're seeing 18 seconds from scratch, and their median is 1 second. So there's all sorts of things that can be going on there. Like, I need to go faster. But the point here is just like no one's adopting based on compile times. So yeah, so one thing that teams are asking for is like, can we get more blog posts? Like, can we get daily online interaction? Can we get more frequent releases? And one way to think about this is like teams, some of them want their languages to look like a startup. It's like you should have marketing, you should have customer service, you should have continuous delivery. And when your organization like Mozilla or Google or Facebook, it's like you have the money to hire for these kinds of roles. And so that can actually be a huge thing when it comes to adoption, is like if people are talking about it, it's sort of something to look at a lot, and you can drive people in that direction. The issue in the case of Elm is like it's expensive to do this, and like focusing on these things, these are like hard work, and it's going to come at the expense of some other aspects. Another thing that's a factor is like there's safety in numbers, where like if everybody's using React and you choose to use React, you're not making a risky choice as a manager. Like you're not going to get fired for, being too out there, or you're not going to have to fight with anybody. And so that I don't know to what extent you can address from a technical perspective. So the other thing to think about is like, what are organizations thinking of all this? And it's like, they kind of don't care. So when I started thinking more about what organizations want, it's like uniformity. We've got 10 million lines, tens of millions of lines. And so if we have C++, Java, and JavaScript, we have people who can hire for those roles. We know what our turnover is going to be. Like you have a predictable system. And if you start introducing 20 languages, like you're just complicating all this stuff and things are going to be incompatible. You're going to build up all these costs. Legal risks, just briefly, I'll say, it seems that big organizations like to work with languages that have like IP that's owned by big organizations. So it's not to say that it's just like the risks are understood. It's like those people own it. If they were going to get sued, they would have gotten sued already. Here's how this is going to look. Whereas if you're like, hey, we want to use Python, but Python comes from before open source was even a term. So like, what is the license under which the contributions from 1992 were made? And the other thing is having control over the future of the language. So in JavaScript, there's this committee called TC39 that makes choices about what features will be added. And membership to have a vote is about $76,000 a year. And so if you're a big organization and you want to have a voice, it's like there's a clear pathway to have a voice. So when you start to look at like, what does a programmer want? It's like, okay, we were really addressing that with learning curve, with render performance, with error messages, and trying to address what teams want from a technical perspective. But from an organization, it's like, there's nothing we can really offer unless this project had started at a big organization where the IP was owned in that particular way and the voting rights were in a particular sort of way. But if you do that, can you appeal to programmers in the same way? You might appeal to teams more, but like you're making some kind of trade-off here. So the last point I want to make is about funding. So if you just think of Elm as a series of technical decisions and blog posts in this, it's like it's missing a major component that I've only recently really come to appreciate fully. So Prezi supported Elm in this time range, and NoRedInk supported Elm in this time range. And throughout this whole time, I'm just like saving up, I'll pay my rent, I'll eat food, and I'll save everything else because this is like a risky thing. These companies can go out of business, and I want Elm to continue even if there's some sort of disruption. So when it comes to thinking about funding, there's like a couple categories that it's interesting to think about. So very briefly, I'm sorry I'm going so long. If your funding is coming from research institutions, that the goal is to produce research. So if you are in the situation where a feature is proposed and you add it, the worst case scenario is like there are some overlapping features and maybe it becomes hard to work on a team. If you reject it, it's like, well, there's fewer publications. Is this really a good research language? So that's a pretty bad outcome in this context. So my sense is that there's a bias to adding features, and specifically features that are interesting features. Whereas in big companies, a big goal is going to be market dominance. So like in the case of Google, traffic acquisition costs are a big deal. So they're spending, or the revenue they're making is like 130 billion a year. And they're spending like 30 billion of that on traffic acquisition costs, which is essentially we're paying Mozilla, we're paying Apple to be default search, because that's driving so much traffic that it's, if they were to choose Bing or to choose DuckDuckGo, that'd be a problem for us. And the revenue that Bing and DuckDuckGo have, they can't even compete with these traffic acquisition costs. So it's like not even viable for them to be in that spot. And so like if a big company has a language and a feature is proposed and they add it, again, it's like there's overlapping features, maybe it's hard to work on a team. But if you reject it, it's like, why is company ignoring users? There might be legitimate technical reasons, but people are going to say, why is this company ignoring us? Is this an abuse of monopoly? Suddenly people are talking about like the monopoly position of these companies. It's just like, this isn't good. This isn't good. So again, I think there's a bias towards adding features. And unlike in a research context, it's adding the features that everybody wants. So you're sort of getting old classics as opposed to new interesting things. And in the context of a small company, the main goal often is hiring. So there's this idea of the Python paradox, where Python was a small language and people would say, well, we shouldn't use Python because no one's using Python. How will we hire? And the Python paradox was this idea is that the number of jobs available, let's say, is 100, and the number of people who learn Python is 1,000. So it's actually really easy to hire for these kinds of companies, these kinds of languages. And then the people who are learning these languages in their free time are like sort of interested in how to do things better. And so you're getting a non-random sample of programmers that could be in your favor as a employer. And so part of why NoRedInk wanted to support Elm was because it really helped them hire people. They had 10 engineers and wanted to get to 20, 30. So in this context, adding the same downside as before and rejecting, it's like, why is this person ignoring potential users? It's not everybody. Elm is some fraction of the overall JavaScript world. And maybe I'm going to use a different programming language. And so the trade-offs here are different, and different language designers are going to make different choices here. So I think there's more freedom to keep the language small under this kind of funding model. And thinking about this, I sort of began to think like, rather than asking, do I like this language, it's like, is this language achieving its goals? So like if a language is trying to have market dominance, it might make choices I don't personally love, but like knowing what it's trying to do and who it's trying, its audiences, it might be doing a really good job. So I'm very out of time. I wish I could say a little bit more, but I hope there are some interesting notes here that might be useful to people. I hope that, yeah, I think the last thing I want to emphasize is like talking about things in blog posts is important, and that when one language from the functional world does well, all the languages do well. So it's worth celebrating any sort of success because you get this crossover of people and ideas. So yeah, thank you so much. Again, it's a huge honor to be speaking at ICFP, and I hope something in this was useful to you. Thank you.
All right, thanks a lot, Evan. We were originally planning to have me deliver a few of the questions from the audience in this YouTube stream, but since we have a more directly interactive Q&A room set up, I think I'll suggest we take all of that there, and Evan and I will join that room in a moment. And I'll just make two announcements, or approximately two. First, we do have our general social time starting now. There will be a delay of an hour and a half until the next technical session, which will be the presentations of Journal of Functional Programming papers, also experimental for ICFP. Two other events happening shortly at about half an hour from now. There's a virtual art gallery, and there's also a session run by SIGPlan Cares, which is here to help deal with any issues with the code of conduct that ICFP and other SIGPlan conferences have adopted. And yeah, I guess that's about all I'll say, except not only do we have these scheduled events, you can also create your own video chats in the people/places tab of the Clouder system, and look for the on language adoption Q&A link in the left of that tab, and you should be able to join our Zoom conversation with Evan. We should both be there pretty soon.